This little box right here can catch a fire before it even starts. This is HazardNode, and by the end of this video, you are gonna know exactly why we built it, what nearly broke us, and where we're taking it next. I'm Rita, and this is HazardNode. Let's get into it.
So picture this. You're Mr. Lim, a facility manager responsible for 20 workers and thousands of ringgits in inventory. When something goes wrong, you're not working in milliseconds. You're relying on minutes. And in Malaysia alone, industrial fire incidents have jumped 24% in just 5 years. Here's the wild part. 76% of those incidents are actually detectable early, if you've got the right system watching for them. So we asked, what if every facility had a nervous system? Not a hardwired, expensive SCADA setup. Something cheap, fast to deploy, and actually smart. That's HazardNode. Let's talk hardware. Each sender node is built around an ESP32 paired with a DHT22 temperature sensor for temperature and humidity, an MQ2 smoke sensor, and an MPU 6050 to catch tilt, so we know if something's about to structurally fail, not just overheat. Total cost per node, around 133 ringgit. For context, a comparable industrial system runs you around 3,500 ringgit to 15,000 ringgit. We're not replacing the factory, we're giving it a nervous system.
So what can we see here is our HazardNode and our conventional sensor. So as we can see here, as I start tilting both of them at the same time, it shows warning on the HazardNode already, but the conventional tilt sensor has not reacted at all. As I tilt it more, it already became collapsed at about like 40 degrees. But the conventional sensor still has no reaction at all until everything is already too late. So here's the actual flow. The sender captures raw temperature, humidity, and orientation data and packages it as JSON. So as you can see in this code right here, it captures the temperature, humidity, pitch, row, smoke analog, smoke digital, and the HAI class. And here we have our lightweight random forest HAI model, which you can see right here. This is the code base. And no cloud round trip needed. It shows the live reading on the built-in OLED screen. Then it sends it through ESP now to the gateway. The receiver uploads that to Firebase over Wi-Fi. If the model predicts a hazard, it fires an alert straight to our Vercel dashboard and a Telegram bot. If not, the dashboard just keeps updating quietly in the background. And look at this chart right here. This is our simulated hazard prediction, and the blue line is our AI predicted hazard probability, and the orange is the actual hazard state. Notice that the AI's probability starts climbing well before the actual hazard state flips. That gap is our early warning window. In our test, that translated into catching warning level condition 15 to 35 seconds faster than the standard threshold. So evacuation typically takes 2 to 4 minutes, so every one of those seconds matter.
Okay, real talk. Version 1 was ugly. We field tested 4 units in our school robotic club for 48 hours, and the feedback was bug. People loved the portability, the dashboard, and the real-time Telegram alerts, but hate the casing. The gateway node didn't even have one, so we went back, redesigned the enclosures, and reprinted it in ABS. Small fix, but it taught us that a great sensor system still needs to not look like a sci-fi reject. If we had more time, 3 phases. First, a 3-month field test with a manufacturing partner so the model trained on real diverse data. Second, refining the sensor for accuracy and squeezing out more battery life. We are already at 72 hours, but we want more, and long term, making predictive edge-based safety a standard every SME can afford, not just the enterprise giants.
That's HazardNode, detecting danger before it strikes.
Check out the dashboard at hazardnode-dashboard.vercel.app.
Thanks for watching, and we are team
HazardNode!